Okay, section 4.2, standard form of a quadratic function. It says graphing quadratic functions written in standard form. So remember that we talked a little bit, I don't remember if it was this class or 7th hour. Mainly when you're looking at parabolas, you think of completing the square, which everybody kind of dislikes doing. This is not it. Okay, so here's some properties. Your standard form is ax squared plus bx plus c. You can have it equaling y. You can have it equaling the f of x. It's just function form versus regular equations. Also, we're going to have multiple properties that we've went through before. So this just kind of lists them again all on one page. Here they are. The graph is a parabola. If this a at the beginning is a positive number, it opens up. We've already talked about that. If it's negative, it opens down. Here's the new parts. Before, we had to either use a table to graph them, or we looked at transformations from the regular y equals x squared graph. So here are some things that you can do that you don't have to necessarily graph. You can still figure some things out, and you don't have to use a table, which is a bonus. So here are the main 3 new ones that we are looking at. Right there. So one of them, the vertex you would find first, they just didn't put it first here. Negative b over 2a, f of negative b over 2a. Axis of symmetry, remember, is the exact same number as your first number of your vertex. And then the y-intercept is 0, c. And we'll talk about what those letters are in a second.
Is the first number of vertex?
Yep. Remember that the axis of symmetry is an equation, though. Many of you put a number. It's an equation. A number is just a number, even if you wouldn't have done an ordered pair or anything. So you have to set it up like an equation. So make sure that you're aware that you do need that x equals there too. So I'll put a note there. Where do the letters come from? When you are looking at this equation at the beginning, do you remember using the quadratic formula before? A, B, C, that's the numbers, and that's what they are in your main function. That's where you're getting them from. So negative b would be that second number, over 2a would be 2 times that first number. So it's exactly like you'd be thinking about putting these into the quadratic formula, and it actually is parts of the quadratic formula. You just don't really realize that yet. The 0c part is if I plug a 0 in for the x, it'd be a 0 for the x squared, a 0 for the x. The only thing that would be left would be the number, c, and that's why it's 0c. So when you look at it, if you plug in a 0, what is left, basically? And it's always the number that's just right there. So once you get used to that, it's really easy to do. So here, what are the vertex, the axis of symmetry, the maximum or minimum value, and the range of y equals 2x squared plus 8x minus 2. We're not going to graph this one. We're just going to do these 4 things. So first one is most important, and that's the vertex. So in the formula, I'm going to write it off to the side here. Negative b over 2a, f of negative b over 2a. So we're going to look at how do you do that? What does that mean? So in your formula, your a is 2, your b is 8, and your c is negative 2. Make sure you grab the signs of each of those if you need to. So I'm going to do what is just negative b over 2a, and I'm going to be a little more specific on this one than I am on the next one. So negative b would be a negative 8. 2 times a would be 2 times 2. Again, I'm going to show you what I'm doing. I would normally just put the number in there. So negative 8 divided by 4 would be negative 2. So far we have a negative 2, f of negative 2. So notice how these two things are the same. Once you get that number, you're just going to plug it in, basically. So how do you find f of negative 2? You substitute a negative 2 in for the x's of the original equation. Okay, so this one I'm going to do a little bit different color here so you can kind of see what I'm doing.
like original equation?
This is like f of x right here.
Oh.
Same thing. It's just telling you what number you plug in. So even if they put a y in there, it's the same. So I'm going to go with this plugged into there. Okay, so f of negative 2 is going to be 2 times negative 2 squared plus 8 times negative 2 minus 2. And definitely you can just plug all of those into your calculator. You don't have to do it step by step, even though that's what I'm going to do. I just don't want to hold my calculator too. So negative 2 squared is 4. 4 times 2 is 8. 8 times negative 2 would be a negative 16, and then minus 2. So f of negative 2 is negative 10. So when they have that f in there, it just means you're looking at your original function, whether it has an f in there, f of x, or whether it has a y in there. You're looking at, I'm going to plug this in, and whatever your x part of your vertex is, that's the number you're plugging in. We'll do this multiple times today. So we have our vertex, negative 2, negative 10. So if we graphed it, we'd go left 2, down 10. This would be one that kind of went in that third quadrant area, but we don't have to graph it this time. Now, how do we know what the axis of symmetry is again? It's x equals what? I can tell just by looking at the vertex what it is. X equals negative 2. Whatever the x part is, that's what it is. So we have 2 of them done. And that's the part where if you did a vertical line at that vertex, it would fold the left side, and it would look like the right side. Then we need the maximum or minimum value. So how do we know what that is? We look at what the sign of this number is. It's positive this time. So I'm going to go to this one. Okay, I'm going to go up just a little bit. That means it opens up. And you don't have to necessarily write that. I think it helps. If it opens up, where's the vertex? At the top of the curve or at the bottom? At the bottom. So would it be a maximum or minimum? Minimum. So I'm going to put vertex at bottom. And then it's going to be a minimum. And when it says the value, now on the quiz, even though it said the value, we didn't really talk about it a lot. I didn't count that part wrong, but from here on out, I will. It's a minimum at whatever the y value is. So the minimum would be this number right there. So a minimum at negative 10. So it's the y part of that one. And even if you got that part wrong, if you didn't put it down, I didn't count it wrong. If you put the wrong number, I didn't count it wrong. I just counted maximum and minimum on that last quiz that you took. On the test, though, you'll have to know that it's the y value. So in parentheses, I'll go y value of vertex. Okay, and we have one more thing to do, and it's the range. So think about this. If you have something that looks like this. Okay. Let's say it's over here. Okay. Let's say this is where our curve is. It was negative 2, negative 10, so we'll pretend that that's where this is. So this number right here is negative 2, negative 10. And it opens up. So for the range is the y values. So if I follow this over, what y value is this number right here? Negative 10. So is it numbers above negative 10 or below negative 10? Above. So we need to say our range is all real numbers greater than or equal to negative 10. Or I probably could go all... no, that's probably a better way to say it. Some say y greater than or equal to negative 10. Did anybody do that on the quiz? If you did that and I counted it wrong, let me know, okay? I'll accept either one. I just don't remember what I did. So it doesn't have anything to do with the domain. The domain would be all real numbers for every single one of these. The range is what changes because the curve kind of bounces all over the place.
So if it was pointed down, would it be all real numbers less than or equal to -10?
Yep. That's the only difference, is if this vertex was at the top and it was going down, you would still follow it over, it still would be -10, and it would be numbers below -10. That's the only thing that changes. Yep, did you have a question too?
Are we getting to domain or are we just?
The domain isn't on this one.
Oh. Okay.
No. No, they only asked for the range on this one. Okay, so still things that we've already done, but hopefully maybe it helps you understand them a little bit more so you can make corrections on that quiz. Okay, so here's another one. This is the got it question. Y equals, and remember this could be f of x equals here. Don't let that part confuse you. -3x squared minus 4x plus 6. We're still doing the same things that we just did. So vertex, I'm going to put it over here when I find it. Okay, so the first thing you're going to do is the negative b over 2a part. A is going to be -3, b is going to be -4, c is going to be 6. If you have to write them down, write them down. If you don't, just look at them. It's okay. So negative b over 2a. I'm going to do a little bit simpler version of it on this one. Negative b would be a -4 or +4. 2 times a would be 2 times -3. And that's a negative in there. So you get -2/3. Not a very nice number, but that's okay. I would say probably don't round on these, especially if it's like a 2/3, which is 0.6 all the way across and then it hits a 7. So my x part is -2/3. Now I need to find my y part, which means plug it in. F of -2/3 would be -3 times -2/3 squared. And you can type this in your calculator for sure. And I don't know what that is. Okay, your calculators will probably give you 7 1/3. I think it usually shoots out the mixed number. Mine shoots out the improper fraction. I like the improper one better. There's just not as many numbers to look at. So my vertex is not very fun. We would not want to graph this one, probably, and it doesn't tell us to anyway. So there's the vertex. What's my axis of symmetry again? X equals, I shouldn't put equals there, -2/3. Then we need maximum or minimum. So what does this negative mean again? Opens down. Yep. So if it opens down, that vertex is the highest point. So it would be a maximum at what? 22/3, and you can do 7 1/3 there if you want. So it's a maximum at whatever the y value of the vertex is. Oops, that didn't show up out there. It shows on mine. There we go. And then the range. Y values over or under? If it's a maximum, it's at the top, right? And it would be it'd be everything under the y value of the vertex. So y less than or equal to 22/3. Or you could do all real numbers less than or equal to 22/3 or 7 1/3. So does the range seem a little easier to understand? now that we've looked at it again? Good. So hopefully your quiz corrections can be pretty simple, or some of them at least. So that's when you don't have to graph them. I think there was one on here. Yep, here it is. Okay, so when you do have to graph, this is much easier than doing all the transformations that we would have had to do. So we would have graphed my y equals x squared. We would have had that on there. We would have had to somehow figure out what that vertex is, move it, that kind of thing. This one is not in a good form to do transformations. So we're going to just do the vertex, axis of symmetry, and another point. Okay, that's the only three things that we really have to do. So vertex is the first one once again. And I'm going to write it in there when I get it. So my negative b over 2a is negative 2. And remember, a is 1, b is 2, c is 3. So negative b would be a negative 2. 2 times a would be 2 times 1. And that's my x part. Then I plug it back in. F of negative 1 squared, plus 2 times negative 1, plus 3. That would be 1 minus 2 plus 3 equals 2. Axis of symmetry is x equals negative 1. It's not telling us to do that, but if you put it on your graph, it's going to make it much easier to do. We also need one more point, and that 0c part is where this comes in. So if I plug in a 0 for the x's, what's left? 0x squared, or 0 squared plus 2 times 0 plus 3. What's left? 3. So my point that I'm going to graph is 0, 3. You can call it the intercept. If they ask you what the intercept of the graph is, it's going to be this point. So I'm going to put y-intercept on there, but it basically is going to give you another point to graph. So we're going to put those three things on there, throw one more point on, and draw it in. Okay, so it's really, really simple to do. Okay, so negative 1, 2. That's my vertex. The axis of symmetry goes right through there. So I'm going to throw a dotted line in there. My y-intercept is 0, 3. And the reason you want to put this axis in there is because whatever it looks like over here looks the same over there. So wouldn't I have another point right there? And that's all you have to put in there. Okay, so when you're looking at it, you have some points. At this point, we really are not super shook up about the number in the front. You know how some of them look fat or like wider than the other ones? At this point, when we're just doing a quick little sketch, it's not super important. Make sure it looks like a curve though, not a V, because V's are not parabolas. V's are absolute values. So make sure it looks like a curve. So wherever that y-intercept is, it's going to have a point exactly on the opposite side of the curve that's the same. And you really only need 3 points to graph it. And this one was an opens up one, right? You might want to jot that in there when you're looking at it so that you don't draw it the wrong way. I've had students, I think that was because my finger was on there. I've had students put these 2 dots on there. And if you don't put that axis of symmetry on there, why? There we go. If you don't put this line in there, they have drawn it opening down before. So you got to pay attention to what points you have, where are they, and if you put that dotted line in there, that's the one that you know, oh, it has to look the same on the left as it does on the right. And then hopefully you'll pay attention to the opens up and opens down thing. So you would get points for the 2 points, but you wouldn't get points for anything else because you're not paying attention to really what the details are. So even though they're graphing, there's not as much on the graph that you have to do, which I think is nice. What is the vertex form of 2x squared plus 10x plus 7? So what do we need in the vertex form? The vertex. So can we do that using our formula that we just learned? Yep. And then we're going to write it in vertex form. So we kind of were doing this last week a little bit. Once we knew the vertex, we could write it in the other form, but we really hadn't learned it yet. So when I'm done, it's going to look like this. And the two things I need to fill in are the x part of the vertex and the y part of the vertex. Now, where'd that 2 come from? This 2 right here, if there's a number ahead of that x squared, it still needs to be there. So if it's a 1/3, carry the 1/3 over. If it's a -7, carry the -7 over. Whatever it is, it comes with it. So let's do negative b over 2a again and plug it in. That's all we're going to have to do on this one. Negative b would be a -10 over 2 times 2. So -10 over 4, that is -5 over 2. If it's a decimal where you don't have to round it, you can use it. So here you could use -5 over 2. You could also use -2.5. Either one works. What do you guys want to use? 2.5? Sounds good to me. And it's negative, so my sign would change. Because it's negative 2.5. Because remember in the formula, when we learned it last week, it was x minus h in there. And I'll jot that down here so you remember why that is. So if you put in a negative number, it changes to a positive 2.5.
Why don't we have 7, like our plus 7 in there?
We're changing it to a different form, so we don't want it in there.
Also, just exclude it.
Yep. It's not really excluded because we're only looking at the vertex point when we do this form. So now we plug it back in. So f of -2.5 here's where it's still included, Av. It's still included when you figure it out, so we're not really forgetting about it. It does make a difference, but you won't see it anymore in the equation. So now we're plugging it in. -2.5 squared times 2. Oops. 2 times. And you get -5.5. This is a negative number, so I'm going back up and I'm changing it in my equation to a -5.5. If it was a positive number, I'd just put it in the blank. So really, the only number that carries over from our original equation is that number that's ahead of the x squared. If it's a 1, nothing really carries over. It does, but you don't really see it. Now, if we had to graph this one, now we would be concerned about the 2. Because there is a 2, we could do more points, but normally they're looking at just the 3, the vertex and then 2 others. And I think we have one more. Do you guys want to do one that opens down, that you're doing the vertex form? Okay. So here's this one. So this one opens down. What number carries over to our new one? This one. -1, x minus something squared, and we're going to fill in those 2 spots once we find out what our vertex is. So what's -b in this one? -4. What's 2a? Yep. So -4 divided by -2 is 2. So I'm going to put that in my first spot. That's the h. And you can do vertex over here if you want to, if that helps. And now we need to find f of 2. Whatever this number is, that's what you're doing f of. And f of just means plug it back in. So f of 2 is negative 2 squared. The negative, remember, is sitting out front. It's not in the parentheses. So negative 4 plus 8 minus 5. Negative 1. That changes the sign again. And that's it.
So we get the negative 1 out in front of the, or like,
Yep, the A part.
yeah.
Yep.
Is that like, no matter what, if there's a number there, it is gonna be like the compression and the stretch?
Yes. Yep. This one, it just says we're going to open it down because the number's 1. So the 1 doesn't affect it, but in other times it will. Like the last one, 2, would be a stretch of 2. Yep. And then we could put that in there. So the 1 didn't really affect ours before. Questions on how you get stuff and, you know, why are the signs changing on the K part? Because it's normally a plus and our number's negative. Okay. The X part, it's normally a minus, so if you plug a negative number in there, it's going to change the sign. Okay, so on this one, they just want you to kind of understand if this was attached to a word problem, so don't get shook about the word problem because they will give you this equation unless we are using graphing calculators, which we might get to on Wednesday. So with this one, the equation's there. You just got to kind of figure out what the numbers mean, and it's super, super easy once you see one. So there's a New River Gorge Bridge in West Virginia. It's the world's largest steel single arch bridge. You can model the arch with this function that's given. X and Y are both in feet. It says how high above the river is the arch. So they do have a picture of this one. You might want to check it out. I'm just going to go to here. So if you are thinking about this, it has a arc like this, right? That's what bridges look like. Go to page, I don't even know. Yep. Okay, so when you look at it, they have the bridge there. Then they took it out and they made a super simple picture, which I kind of did as well. So if we knew what this point was right here, which is the vertex, the X part is how far out this way it is, right? What does this one stand for? What value is that? How tall it is? The what? The Y value, right? So when you're looking at it, it looks like it's got to be something super complex that you do. If you can find out what the vertex is, the Y value is what they're looking for on this one. So how high would just mean find Y value of vertex, which is what we're going to do. So even though the numbers are super ugly, it still works exactly the same. So we're going to do negative B over 2A. And by the way, what's C on this one? There isn't a number, is there? So this one would cross at 0, 0. So this point right here would be 0, 0. So if you're thinking what happened to that extra number, it's there. It's just nothing. So the 0.847 is our B. The negative number is our A. So negative 0.847 divided by 2 times negative 0.000498. And definitely, since these are decimals, leave them that way. This one gives me about 850.4. So I'm going to leave it about 850. So moving to the right from 0, 0, it's about 850 feet. That is the X part of my vertex. Now I need to find the Y. And it just means plug it in. Okay, so now I need to look at my numbers. Okay, so negative 0.000498 times 850 squared plus 0.847 times 850. And I think if you calculate that out, you get about 360. Since we rounded the first one, we're going to round the second one as well. And that's the one that we want. So how high above the river is the arch? 360 feet. They left these in kind of step 1, 2, 3, 4, whatever. Or is it the height of the, okay. What we really found though is just the height of the arch though. So it's not really the final answer to that question now that I look at it. I should have left a little more space. Okay, so I'm gonna go back. Don't circle that box yet. So the bridge itself is 360, right, from here to here. How high is the bridge from the water? I think it tells in the question. It's like 516 feet, or it tells in the picture or something. Yeah, so the bridge is actually 360, but the height above the water is 516. We would add those together. So I'm gonna add 516. Top of the bridge to the water, 876 feet. So now, how long is the bridge from this side to this side? Well, if you look at where the vertex is, isn't it in the middle? So the middle, like the axis of symmetry would kind of cut it in half. So if it's 850, the x part from 0 to the middle of the bridge, wouldn't it be another 850 on the other side? It has to be symmetric. So on the second one, I'm going to draw a little picture here. This point right here, remember, is 850, 360. So from here to here is 850. From here to here is another 850. So 850 times 2, 1,700 feet. So you got to kind of think about what the things mean. So even though we've been doing vertex, axis of symmetry, throwing in extra points, what do the values mean? What does the vertex mean when you're actually looking at it? So you would take half of it, double it, and you get the 1,700. I believe that's it. So I just was thinking that the next question was, you know, how far to the water? I just didn't leave enough room.